Today we're going to be doing an installation on a existing well. It's an 8-inch casing, and we're going to install a model 125, which is a 5-gallon per minute pump cylinder. There's complete installation instructions in a written format that you want to review completely. What we're going to show you today in the video is not intended to be 100% in sync with what's written. There's a lot more information in the manual. When you receive your pump system, the drop pipe kits are going to come in a 9-foot spiral wound fiber tube. The male threaded ends are going to be protected with a plastic cap. You just need to remove that cap. The sucker rods are shipped, 9-foot sucker rods are shipped inside of the drop pipe. Now the ends of the spiral wound fiber tubes are wrapped with stretch wrap and tape. But in rough handling during the shipping process, we've had several occasions where the sucker rod has come out of the shipping tube, and then in the terminal it's gotten bent upon itself by either a forklift going by or something, and when it gets bent upon itself, it basically fractures the fiberglass. The fiberglass is great in tension but not in compression or bending. So what's probably a good idea is, with each sucker rod, you just very carefully examine the sucker rod to make sure that it wasn't bent upon itself or there are no imperfections in the outside diameter. It should be rather smooth. You want to be careful though if it has been bent over and you run into the portion of it where there may be some fiberglass shards. It could be a little, you don't want to get a fiberglass sliver in your hand, but just be aware that you need to examine the components before they're installed down the well. The first step is to take the either Model 100 or Model 125 pump cylinder, having a stainless steel piston rod protruding about 5 inches. You're going to make an initial connection between the male threads on the piston rod and the female threads on the very first sucker rod, to the point where they are shoulder to shoulder, making sure that they're tight. The ideal situation is for you to apply 3 wraps of Teflon tape on the male threads, and then bring the sucker rod into the male end that you've protected with Teflon tape or covered with Teflon tape, and bring the male to female and thread the male into the female bushing that's in the upward end of the Model 125 cylinder. Now if you have a Model 100 cylinder, there is no bushing. It threads directly into the stainless body of the pump cylinder. The amount of torque we want on this is we're about hand tight. We want to maybe half a turn past hand tight. These are National Pipe threads. They're tapered, so there's no need to run them together with heavy pipe wrenches or a lot of torque. We have a 10.5-foot assembly comprised of the 18-inch pump cylinder and the 9-foot drop pipe. The sucker rod's in it. It's been threaded in Teflon tape. We're going to introduce the simple pump systems through the split flange that's mounted to the well cap. The 3 bolts on the top of the split flange should be slightly loose, and the pinch bolts should be loose. Then we're going to have our safety tool handy, and we're going to introduce the pump cylinder through the split flange. Now there's a 224 Bunarubber O-ring in there that might provide a little bit of restriction, but you have to deal with that perhaps using a little Vaseline or something if it's more difficult to introduce. The safety tool then is placed on the 3 bolt heads that are mounting the split flange to the well cap. You bring the bell end of the pipe down to rest in the safety tool, and then place a rod guide over the protruding sucker rod. It'll shinny down into the bell end area where it is not threaded. You'll notice that there's about 5 inches of rod protruding. We had the same amount of protrusion at the piston rod relative to the pump cylinder, so we're going to try to maintain that distance to the surface, and in order to try to maintain that distance, we're going to want to have about 5/8 of an inch of thread engagement between the male and the female pipe ends. So we're bringing the female into contact with the male threads, and we're rotating it down. Now we've reached the point where the mechanical disruption of the threads on the female skirt are making contact with the end of the male thread. So we're going to try we're going to want to move the two parts shoulder to shoulder, being careful not to over torque. But there, we're just about there. There we go. Shoulder to shoulder, tight, mechanically locked. This is the second 9-foot length of drop pipe. Once again, we're removing the protective cap. We're going to put a little Teflon tape on the threads, 3 wraps. And as I mentioned, 5/8 of an inch of engagement between the male and the female is about a half a turn past hand tight. You can move the sucker rod over a kind of a sweeping 90-degree arc, bring the end of the sucker rod into the drop pipe, bring the drop pipe down to where the threads engage, and now we're looking for half a turn past hand tight, or 5/8 of an inch of engagement. On all simple pump systems with more than 12 drop pipe kits, we always quote and include a T-handle assist tool for the residential installer. The T-handle assist tool changes the relationship between you and the pipe to where it's more like a handlebars on a bicycle or weights at a gym. It just gets threaded into the upward female bell end, and then we bring the end of the pipe over the rod end. The Teflon tape would have been applied to the threads in advance, and we bring it into position. We thread the male into the female. Again, the half turn past hand tight. There we have hand tight. About it. Now we release the safety tool, and having the T-handle assist tool to be able to lower the string of pipe as it picks up weight, keeping in mind that each 9-foot section weighs 5 pounds. Now we have a much safer, much more predictable way of introducing the bell end into the safety tool. Once it's in place, we simply unthread the T-handle assist tool, and we're on our way. The standard configuration for the simple pump is we provide a 1 inch by 2 inch stainless nipple. And what we're looking at here is when the nipple is in place over the last protruding sucker rod, we want to show 5 inches of rod. This looks to be almost perfect in terms of the amount of rod protruding, but let's say we had a situation where there were 25 drop pipe kits, and on every one we gained 1/8 of an inch because whoever was installing threaded the males into the females further than we would have anticipated. Then it might be necessary, if this is sticking up maybe that far, that we would have to use a longer nipple. And the ideal dimension then again between the top of this nipple once it's engaged would be 5 inches. So that would place the stroke of the piston inside of the cylinder at the bottom in the correct orientation relative to the lever arm at the surface. In this case, the standard one is going to work just fine. The next step is to bring the 3/4 inch stainless pump rod and thread it onto the upward facing male end of the top sucker rod. There are flats at the top here that you can grab hold of with a channel lock or a crescent wrench just to get a little torque on there. Then the next piece that we're going to bring in is the riser tube and pump head. There's a 8-inch long rod gland inside of the pump head, so we want to align that stainless rod to relate to that. Again, some Teflon tape on these threads would probably be in order. Three wraps would be good enough. Now we are ready to remove the safety tool, lifting up a little bit on the bell end. We're going to tighten up the pinch bolt on the split flange. In this particular case, we don't need a whole lot of simple pump riser tube above the well cap because our well cap protrudes about 16 or so inches. Tightening down the 3 mounting bolts on the split flange. The 24-inch or 36-inch lever arms are supplied pre-assembled to the extent that we can. We assemble the clevis, the 2 brass shims, and the clevis pin, and then the mating mechanism, the lever bracket, the lever link arm, and the clevis pin in the shims. The easiest way to put these 2 pieces together, and actually suggests that you do it before trying to attempt to assemble them to the pump head, is to put them on a flat surface and introduce the first shim between the 2 mating parts. You're going to want to have either a small screwdriver or something just to reach. I'm going to use an Allen wrench here, but you can use a little screwdriver if you have one, to be able to reach inside and just kind of center that. And then we push the pin through part way, then flip it over, back the pin out just a little bit, install the brass shim. Again, might have to have a little help from a screwdriver or something to get it positioned. And we're good to go. We're bringing the clevis into position above the 3/4 inch stainless rod, and we're threading it into position. The threads at the top of the stainless rod and in the clevis are left-hand threads, so you tighten them by going counterclockwise. And there we are. Now the lever bracket is brought into position. It may be necessary to lift up on the pump head just slightly to get the holes to align correctly. We got one started here. There are 4 of these 1/4, 20 1/2-inch long stainless cap screws that just need to be snugged up. Okay, now we're going to install the 3/4 inch nipple, as well as the, well, there's one, the way the pump is shipped to you, this is what is supplied, unless you've also ordered the check valve and the gauge. But this is the standard configuration with a stainless nipple here, and the garden hose adapter. We're going to take the garden hose adapter back off and show you what the check valve and the gauge looks like. Check valve is a no lead brass check valve, and there's an arrow on the check valve indicating the direction of flow. Obviously the water's coming out this way. So that goes into position. Okay, the next component that's assembled to the body of the check valve is another nipple, and then the garden hose adapter. And then there's a 0 to 100 psi gauge that threads into the port on the body of the check valve. And we also provide you with a plug to plug the gauge port should you decide you don't want to have it mounted. The water in this well is down about 60 to 65 feet, and it's going to take about maybe 50 or 60 strokes to get the water flowing again. So we have the check valve and the gauge there, and this is a full 10-inch stroke. We would measure the 10 inches or 10 3/8 inches of stroke by placing a magic marker indication on the 3/4 inch stainless rod and then observing just how far the rod travels. That is a full stroke. A full stroke is when the lever link arm makes contact with the lever arm at the upright position, and this is a very common position for the pump to set at when it's at rest. And then the other end of the stroke, the lever link arm makes contact with the lever arm there. The normal at-rest position for the lever arm is vertical. You may be able to use a gate valve on the outside wall of your home, but if your home is newer and you have freeze-proof or anti-siphon valves, you can't pump backwards through those. So you have a yard hydrant, you have a spigot, or you have the drain at the base of your pressure tank. If you're going to use a hose to deliver water to your pressure tank, you're going to want to make sure that you use an RV drinking water or a hose that's rated for drinking water. And just make your connection there. And then this is a 50-foot hose, so we'll take a little bit to get some water through it, but it shouldn't take too long. And there we have water going to your pressure tank.